Hello, and welcome back to another episode of the Snowflake Snowpro Advanced Architect Certification In-Depth Training Podcast, brought to you by Brightflux. I'm your host, Yaqub Abdul Hakim, a certified Snowflake user. Today, we journey into the intricacies of key pair authentication in Snowflake, a crucial topic for episode 38 of our series. Key pair authentication stands as the cornerstone of Snowflake's security mechanisms designed to ensure that data access is both secure and controlled. Let's start with the basics. Key pair authentication in the realm of Snowflake enables enhanced security by utilizing a public and private key pair for authentication. Unlike traditional password-based authentication methods, this mechanism leverages asymmetric cryptography where the public key is shared and the private key is kept secret to authenticate a user or service. Why is this beneficial, you might ask? Well, first off, it significantly reduces the risk of credential exposure. Passwords can be guessed, intercepted, or even exposed through human error. However, with key pair authentication, the private key remains undisclosed, safeguarding against such vulnerabilities. Moreover, key pair authentication facilitates automated and scripted processes. It allows for seamless integration into continuous deployment pipelines and other automation tools, making it an indispensable tool for modern cloud-based architectures. Additionally, a notable aspect of Snowflake's implementation is the ability to rotate key pairs, enhancing security by regularly updating the keys without disrupting service. Now, how do you set it up in Snowflake? The process involves generating a private and public key pair with various tools available for this purpose. Once generated, the public key is then uploaded to Snowflake and the private key is used for authentication. Here we encounter various options. For instance, key generation can be done using open source tools such as OpenSSL or through programming languages that support cryptographic operations like Python and Java. Each option comes with its own set of advantages and intricacies. Furthermore, managing key pairs in Snowflake is streamlined through the use of Snowflake's user and role concepts. Users can be granted specific roles that determine their access level, and these roles can be associated with the key pair, adding an additional layer of security and access control. In addition, Snowflake provides robust options for monitoring and auditing authentication attempts. This includes detailed logs that track both successful and failed attempts, offering insights into potential security threats or operational issues. Lastly, it's imperative to understand the best practices when utilizing key pair authentication in Snowflake. These include regularly rotating the key pairs, using secure methods to store the private key, and conducting periodic security reviews to ensure compliance with organizational and regulatory standards. As we conclude, remember that mastering key pair authentication is pivotal for securing your Snowflake environment. It not only strengthens your security posture, but also facilitates smoother operations and compliance with various standards. I hope today's deep dive into key pair authentication enlightens you and empowers you to confidently implement and manage it within your Snowflake architectures. Thank you for joining me, Yaqub Abdul Hakim, on this informative journey. Stay tuned for more episodes that delve into the core components of Snowflake's architecture, helping you prepare for the Snowpro Advanced Architect certification. Until next time, keep exploring and innovating in the Snowflake ecosystem.